Okay, to start, let's do a quick review from when we needed to graph linear inequalities. Remember, we look at our equation over here, and since y is all alone, it's solved for y. We are ready to use slope-intercept form. Slope-intercept form, we have y all alone, we have our inequality symbol, we have x, and in slope-intercept form, remember what we need is to have an addition symbol, so we change this into plus -1. This number, the number all alone, is always your y-intercept. The coefficient of x, or the number attached to x, in this case 1, is always your slope. So we'll start with our y-intercept, which we said was -1. We'll put our first dot on the y-axis at -1. The slope is 1, and if our slope is 1, we want to turn it into a fraction of 1 over 1. We rise 1 and we run 1. So rise 1 and run 1, and I like to put as many dots on there as possible and reverse the pattern. And then when we connect the dots, we have to look at our inequality symbol. This inequality symbol, the inequality symbol right here, has an equal sign underneath it. It says greater than or equal to. In that case, we will connect the dots with a solid line and put arrows on both ends. Now, we need to know which side to shade. We always shade the true side, and I don't know which side is true, so I have to test a point. I always prefer to test 0, 0. Remember, you can test any point as long as it is not on this boundary line, and 0, 0 is not on the boundary line. So I like to write myself a little note that I'm testing 0, 0, and we use that information to substitute. So our original inequality was y is greater than or equal to x minus 1. I'm going to change y into 0 because this is a y value, this is our x value. Y gets changed into 0. Inequality symbol, x changes into 0, subtract 1. Simplify the right side, 0 minus 1 is -1. 0 is greater than or equal to -1, and that is true. 0 is bigger than -1. I tested this side of the inequality symbol, or excuse me, I tested this side of the boundary line where 0, 0 is located, and that was true. So I'm going to lightly shade the side that is true. Lightly shade the side that is true. If I would have tested that point 0, 0 and it was false, then I know I would have had to jump across the boundary line and shade the other side. One side is always true, one side is always false. Alright, so there's a little review from graphing linear inequalities. Moving on, today, or in this lesson, one thing we got to make sure we remember how to do, again, this is from a long time ago, we have to make sure that we know how to solve for y. In this first problem, 9x plus 3y is less than 3. I see a 3 attached to the y. I'll cut it down the middle. There's addition on this side. The inverse of addition is subtraction. I need to subtract 9x. Subtract 9x. The 9x minus 9x cancels, turns into 0. Leaves me with 3y is less than 3 minus 9x. I know I have to solve for y by getting y all alone, so I know I'm going to divide by 3. Got to divide this whole side by 3, so I use a big fraction bar. 3 divided by 3 turns into 1y, so now I have y is less than. Now, on the right side, I have to divide everything by 3, and I like to draw little arrows to remind myself, oh yeah, I have to divide each term by 3. So it starts with 3 divided by 3, which I know is 1. There's a subtraction sign, so I bring the subtraction sign down. I do 9 divided by 3, and I get 3. And there's an x attached to that. I have now solved for y. This is acceptable since we've solved for y. It's probably not the most preferred since it's not in slope-intercept form. Remember slope-intercept form? I usually want my term with x in front. But to switch these around, to move the 3x to the front and the 1 to the back, I have to be using addition. This is subtraction, so I could change it into 1 plus -3x. This is acceptable. Now that it's addition, I might want to switch it around to make it slope-intercept form. Y is less than -3x plus 1. This is likely the most preferred method, but all three of those are correct because all three of those have y all alone. Okay, so moving on then, the next one, same thing, we got to solve for y. We have to get y all alone. Let's see, I need to get rid of this x, so I'm going to subtract an x. Subtract an x on both sides. X minus x turns into nothing. So I have 0 minus y. Well, that's a negative y, and some kids want to put a 1 there. That's fine. Negative 1y is greater than 10 minus x. That's what I've got so far. But to solve for y, we need to get y all alone. So I'm going to divide by the coefficient of y, which is negative 1. Divide by negative 1. Divide this whole side by negative 1 with the big fraction bar again. Negative 1 divided by negative 1 turns into just plain positive 1. So I have y. On the right side, I have to divide each piece by negative 1. 10 divided by negative 1 is negative 10. There is a subtraction sign between the 10 and the x, so I'm going to bring down a subtraction sign. And then I have to do x, which is really 1x. 1 divided by negative 1 is another negative 1 with an x attached to it. And I think back to chapter 1, subtract a negative is really just adding a positive. So I have y on the left side. On the right side I have negative 10 plus x. There's an inequality symbol, a greater than symbol, but if we think way back to early in the school year, we know that if we divide both sides of an inequality by a negative number, which we did here, we have to flip the inequality symbol. So this is solved for y. It's not in slope-intercept form. If we prefer slope-intercept form, we need the term with x to be in the front. So I have y is less than, I'm going to move this over here and this over here, 1x plus negative 10. Now it's in slope-intercept form. And the third one, again, we want to get y all alone. So here's y. I need to keep the y there. I need to get rid of x by subtracting x. X minus x is gone. 0 plus y is just y. If I read the right-hand side, it says negative 3 subtract x, so that's what I'm going to write down. This is acceptable because y is all alone. It is not in slope-intercept form at this time, so to do that, I know I need to have addition because I want to have the term with x in the front. So the only way I can move this here and this here is to change it into addition, and I can do that. Y is greater than negative 3 plus negative x. This is acceptable. Or one more, y is greater than, now it's time to move these two pieces around, negative x or negative 1x plus negative 3. All of those are acceptable. This last one is probably the most preferred since it's in slope-intercept form. All right, now that we've reviewed things, we're ready to move on to the new stuff. Okay, we'll be working with systems of linear inequalities. So again, it's the same as what we reviewed to start, a linear inequality, except now we're not just going to have one on this graph, we're going to have multiple. And we'll just put two linear inequalities on the same coordinate graph. Here's a sample. I'm not going to go through that one, but let's go through this one first. So it's a good idea to use color or maybe a pencil and then a colored pencil. I'm going to do the top one in red and the bottom one in green. This top one is already in slope-intercept form because y is all alone. So I see the y-intercept for the top one is a negative 5. First dot goes at negative 5. I see the slope is negative 2. The coefficient of x is negative 2, and I want that to be a fraction, negative 2 over 1. So I'm going to rise and run. Rise negative 2 means go down 2. Run positive 1. And I want to put as many of those dots on my graph as I can. That way I'm sure that I get a nice straight line. Just follow the pattern here. Okay. I look at the inequality symbol. It has an equals, which means I need a solid line. Hopefully you can get a straighter line than I just drew. And just like we did in the previous lesson, we need to test a point. So for the red one, I'm going to test 0, 0 because it's not on the line. So I'm going to rewrite this equation, the top one, substituting 0, 0 for x and y. So it says 0 is less than or equal to negative 2 times 0 minus 5, or plus negative 5, however I want to think of that. I've got 0 is less than or equal to negative 2 times 0 is 0, minus 5. 0 is less than or equal to negative 5, and that is false, because 0 is actually bigger than negative 5. So I tested 0, 0, and it was false, which means I need to jump to the other side of the boundary line and shade that lightly. So I can do that with some of these shading tools here. Let's use a highlighter. Maybe I'll use yellow over that one. Okay. Again, I want to shade that lightly because I still need to be able to see my graph. And it goes something like that. So everything shaded in yellow is a solution to that top inequality. The bottom inequality, the one that I circled in green, is in slope-intercept form already because y is all alone. Some kids get concerned, they say there's no y-intercept. Well, plus 0, the y-intercept is 0. The slope is 1/2, rise 1, run 2, rise 1 and run 2, and just keep doing that. And I do need to reverse the pattern. This is why we shade lightly so we can see what's in there. And now, if I look at this inequality symbol, it is a dashed line. So I want to get a nice straight dashed line. I can use one of these tools here. So I get a nice straight dashed line. There we go. So I got a pretty decent straight dashed line. Now again, I need to test a point. I like to test 0, 0, but it is on the line. I'm not allowed to test that. So I'm going to pick something, again, that's easy. I'm going to pick 2, 2. Walk 2, rise 2. Walk 2, climb 2. So that is off the green line. I'm able to test that. So I'm going to test 2, 2. I'm going to change the y into 2. Less than 1/2 times 2. 2 is less than half of 2 is 1. That's also false. So that means everything above this green boundary line is false for the green line, or for the green inequality. So I have to shade the true side. So I jump across the boundary line. I'm going to shade this time with green. And I shade everything below the green line in green. Now notice there is an overlap here. There is part that got shaded both green and yellow. This area that I'm going around now with black got shaded twice. So what I like to do is color that part in dark. And this is what it all stands for. This area that just got shaded dark is the solution to the whole system. Everything in this dark shaded area will work for both inequalities. Anything that's shaded only green will only work for the second inequality that says y is less than 1/2 x. Anything that's only shaded yellow will only work for the top inequality, y is less than or equal to negative 2x plus negative 5. Give the second problem, in this case problem B, give these a shot. I'm going to use green for the top one, blue for the next one. Stop the video and give those a shot. Alright, so we're back. I'm going to go kind of quickly. The green one, y is greater than x minus 1. The y-intercept is negative 1. The slope is attached to x is 1, which is 1 over 1. Rise 1 and run 1. I know that all my dots are going to go like this. I need to connect those dots with a dashed line. There's my dashed line, arrows on both ends. I need to test a point. I'm going to test 0, 0, and that will say 0 is greater than 1 times 0, which is 0 minus 1. 0 is greater than negative 1, and that is true. 0 is greater than negative 1, so I need to shade the top, or where 0, 0 was. So I'm going to shade lightly in green above that line. There we go. Next, the one in blue, the y-intercept is 4. 1, 2, 3, 4. My slope is 3. Rise 3, 1, 2, 3, and run 1, and rise 1, 2, 3, and run 1, and reverse the pattern. And now I've connected the dots with a dashed line. And I'm going to test 0, 0. I've already written it up here. 0 is less than 3 times 0 plus 4. This turns into 0. So I've got 0 is less than 0 plus 4. 0 is less than 4, and that is true. So I'm going to shade the side that is true. All right, I've shaded the side that's true in blue, and this area here got shaded blue and green, so this is the dark area.